Hi guys, in today's class I'm going to review the topics you learned in the last two sessions, that is using the distance formula and classifying the polygons based on their lengths. So in today's class you will be able to revise to compute the distance formula and classify the polygons based on their lengths. That's the objective for the day. And a really quick distance formula in the previous two sessions, you learned that it is x2 subtract x1 whole square plus y2 subtract y1 whole square under the square root. Actually, this is derived from the Pythagoras theorem. So, technically, if you take this one, suppose if you are given a Pythagoras, a right angle triangle, and in a right angle triangle, suppose if this one is given on a graph sheet, you know that how to compute. You can count the number of blocks on the vertical line, right? And even on the horizontal line also, we can count the number of blocks, and we can say that what is the length. But when it comes to the hypotenuse part, it is not. It is neither a vertical line nor a horizontal line. So to figure out what is the length of this one, there we use the distance formula. In fact, we derived the distance formula from the Pythagoras theorem. Okay. Then moving to the questions. These kind of questions we discussed in the previous sessions, but quick recapitulation. Let me identify the points. This n is the value of x is -2, and the value of y is 0. I'm sure that you know how to label this one, and I see that the value of x is 3 here, and the value of y is -5. While identifying the points also, please be careful, because if you mess it up, I know that some students the value of x and the value of y, they flip it and they take it. So please be careful, spend sufficient time. You can take any of these points as x1 y1 and the other point as x2 y2. You can take, for that matter, the other way around. For example, point B can be taken as x1 y1 and point A can be taken as x2 y2. One more important thing is that you know the distance formula, which is x2 subtract x1 whole square plus y2 subtract y1 whole square. In case if you want, if you write it backwards, if you take x1 minus x2 whole square, please see that this is not matching with the prescribed formula, but still this is acceptable. Plus y1 minus y2 whole square. So the order doesn't matter, whichever the order you write, x1 x2, like x2 minus x1 whole square, x1 minus x2 whole square can be taken. Okay, back to this one. Here, first of all, I identified the points and I labeled them as x1 y1 x2 y2. I personally prefer to write the formula every time so that I will never make a mistake. Distance formula is x2 subtract x1 whole square plus y2 subtract y1 whole square. This is under the square root. Now let's plug in these values. The value of x2, I see that 3 here, and value of x1 is -2. This is the tricky part. Negative 2. Oops, let me take the same color. Okay, -2. So I see that there are the double negative signs. So in such case, you take extra parenthesis here. Okay, again I'm repeating. Here I see that double negative signs. Therefore, let me put the negative value in parenthesis and the entire part or the entire calculation part in the big parenthesis. Then whole square plus y2 value. You see that y2 is negative 5 and y1 is 0. Therefore, it is a negative 5 subtract 0. I don't see any double negatives, so let me keep just a normal parenthesis. Okay. So if you have this kind of double negative sign, actually most of you can compute in your mind that is negative of negative, it is positive. But still, I strongly recommend to write an extra step. It is 3 negative of negative positive 2 whole square plus negative 5. Here I am not doing any simplification, so just I copied the above step. So 3 plus 2, that gives me 5 square plus negative 5, take away 0, that gives me negative 5 square. Uh, so 5 square, that gives me 25. Then 5 square, that gives me 25. So 25 plus 25, that gives me 50, 50. As I told you earlier, in case if you are taking a test, suppose if the answer is given something like, say, 5 root 3, next, say, 5 root 2, and C, 5 root 5, and D is maybe 2 root 5. Okay, but I know that none of these values are matching with the answer whatever I got, right? So in such case, what I suggest you is, so you change square root 15 to a decimal, change this one into a decimal, and also all these numbers, type on calculator and change them into decimals, decimals, and one of them will match with what are the answer you have trained for sure. Or else if you want to go beyond this one and compute, I know some of you can compute and some of you may be having tough time. So what I'll do is, let me move this part. Oops, my apologies. Yes, let me move these little down. Okay, and I'll show that how to simplify further what is the value of square root of 50. So how to do that means, let's say that 50, and think of prime factorization. That means take prime numbers and go for division. The smallest prime number, you know that it is 2. 2 times 25, that gives me 50. And can I divide 25 by 2? No. Then by 3, obviously no. Can I divide by 5? Yes, it is. So 5 times 5, 25. Then again my next prime number, which is 5 again. No, 5 ones are 5. So just compute until you get 1. Okay. Now the value of 50 equals to, it is 2 times 5 times 5, or maybe, yeah, you can write in any order. So 5 times 5 times 2, it's one and same. Okay, and I know that what is the square root of 5 times 5 means, I hope you remember, while computing the square root we look for a pair, and here I have a pair, or else square root of 5 times 5, which is 25, square root 25, that gives me 5, and square root of 2 I can't compute, therefore 5 root 2, this is the final answer, right? So this is matching with this one, this is matching with this one, so the option B is the answer for the given question. Or else if you have any difficulty, what you can do is, In case if you are given options, you may stop working here, you may stop working here, and that one can be converted into decimal. And here also, when you convert all these values into decimals, then you see that option B will be matching. Now, any questions on this particular problem, how to use the distance formula? All right, let's go to the next question. Find the distance between 5, 9 and -7, -7. Once again, I'm reminding you that if there are negative values, you have to be extra cautious, extra cautious. And it is a best practice to label the given points like x1, y1, x2, y2. Okay, even the next question also I'm marking x1, y1, x2, y2. Okay, then again, as I told you before, always do write the distance formula every time. Don't be lazy. So you can write x2 minus x1 whole square or x1 minus x2 whole square. Better not to get confused. Let's follow the same rule again and again. So y2 subtract y1 whole square under the square root. Okay, then here I want you to try on your own. So you may take a paper and pencil and start working on it, and I'll disclose the answer after a while. I want you to try question number 2. Okay, now your time starts. Okay, let's see how to solve this one, and you may check, you may compare your answer with my answer. I see that here x2 is -7. I see that x2 is -7 and x1 is just 5. Therefore, x2 subtract x1 is 5. I see that there is no double negative sign, so let it be the same. Plus y2, which is -7, subtract y1, which is 9. Therefore, -7 subtract 9. Thankfully, there is no double negative sign. And here, let me not forget to keep the square root sign. So -7, -5. Most of you think that, so let me subtract, then 7 take away 5, it is 2. It is not exactly. Actually, these two values are having the same signs. Please see that both are having same signs. Please do remember, if two values are having the same sign, then we have to add them. So once when you add them, you get that 7 and 5, that gives you 12, and we keep the same negative sign. So it is -12 square. Likewise, in the next one also, I see that -7, -9, both are having negative sign. So same signs, please do remember. We add them. So I get, and we keep the same sign, -16 square, and this one is under the square root. At this point, let me grab my calculator, and I know that 12 square, that gives me 144, and 16 square, that gives me 196. Then, but still, let me make sure that everything is right. So 12 square is 144, 16 times -16, yes, oops, see, it is 256, it is not 196. Oh, so yeah, it is 14 square is that. My apologies, this is 256. Now, let's add 256 plus 144, that gives you 400, square root of 400. Uh, you know, You can use calculator, or else just I am writing 20 times 20, that gives me 400. So square root of 20 times 20, the answer is 20. Therefore the distance between these 2 points is 20 units. It's pretty easy. You may check with your answer, and whoever got 20 as the answer for your question, that's the right thing. Okay, so let's go to the next question. Then here, let me write again distance formula, and I expect you to write the same, which is x2 subtract x1 whole square plus y2 subtract y1 whole square, and this is under the square root. Okay, now you may plug in the values. Please be careful while writing the values. If you want, I'll help you out with this. No. I want you to try on your own. Take a paper and pencil and start working on this. Your time start now. Actually, you can plug in these values, but please make sure that you are writing in the proper order, and double negative signs I see here, right? Then already I worked on this, and I'll show you the final answer. You have to check whether you copied this way or not, this part. So double negatives. Okay, so I worked it for you, and I'm going to disclose the remaining part of the answer. Here the negative 2, negative of negative, that gives us positive 6 square. Next negative 10, negative of negative, that is positive 10 square, right? Then I see that negative 2 and positive 6 means these two are having different signs. So different signs means we go for subtraction. Then 6 minus 2, that gives me 4. And the highest value, that is irrespective of the signs, that sign is to be taken. So that is positive 4 square. And next, negative 10, positive 10, they are different signs. Therefore, we have to subtract. As I told you before, I'll end up with 0. Then okay, then 60, then you'll get a square root of 16 plus 0. My bad, I forgot to keep a square root symbol here in the middle. Okay, well, any questions on this? You may please compare your answer with my answer, and if it is matching, thumbs up, and if it is not matching, you have to check your steps carefully. Okay, well, let's go to the next question now. Let's go to the next question. Suppose a circle C has its center at the origin. So what is origin means? Actually, if you take a graph sheet, then the point where x-axis and y-axis, these two intersect, that point is known as the origin. You know that the value of this point is 0, 0. Right? So origin means this point is 0, 0. And next, I see that there's a circle. So let me draw a circle. Okay, so I'm going to draw a circle. Well, let me copy this. Oh, one moment. So let me copy the circle properly so that the center is the origin. Yeah. Now, this circle contains point negative 4, oh, okay. So let's say that this circle is containing a point which is negative 4 comma 0. So just I am marking this one as negative 4 comma 0. So this circle contains this point. Okay. So the next one is does the point 04, okay, lie on the circle or not? So this point could be on the circle or outside the circle or inside the circle. I'm not really sure. Okay, let's do one thing. Instead of 1 point, let me take 2 points. Okay, so 1, 3. Okay, let me name them as a point P and point Q. So let's check for both the points. So I don't know whether these points are on the circle or not. Okay, so let me assume that the points are somewhere. I don't want to mark. Say that. Okay, so first of all, let's try to figure out. I hope you know that the length of the line segment from the center of the circle to a point on the circle, this is known as radius, right? Okay, now let's assume that another point is say if it is on the circle, then the length of radius should be equal to this one. Suppose if the point is outside the circle, then the radius should be shorter than this length, right? Suppose if it is inside, then this point, that means the length of this line segment should be shorter than radius. Okay, anyhow, just I'll explain this one. Let's do one thing. Let me find the length of OA, which is the radius. Let me find the length of radius, which is OA, right? And also let me compute length of OP, and length of OQ, all these three separately, and then we can compare how it goes. Okay, so let me minimize, let me zoom out so that I'll have more space. Just a moment. Let me move this one to a little right side so that I'll have more space for working, and these things to a little this side. Okay, so let me draw some lines so that they may not overlap on each other. Okay, right. So let me compute all these three parts. So let me start working on the first one. Due to lack of space, just I am writing a little close, please excuse me. Distance is equals to x2 subtract x1 whole square plus y2 subtract y1 whole square under the square root. Now I want you to try on your own. Okay, so just a moment. Let me copy this one here, and let me copy the same formula here, because we are going to compute it 3 times. Again, it's overlapped, so let me move this a little. Oh, my apologies. I'm sorry. This point is still here. Okay, so this is -4, 0. All right. So you may compute on your own, and I'll compute all these three parts. So OA means horizon is 0, 0. Horizon is 0, 0, and point A means that is this one. Okay, which is -4, 0. So I'm giving you the clues also here. You may name them as x1, y1. You know that this is the first part, x1, y1. This is the second part, second point. And when I take OP, again, these points are O is, you know that it is 0, 0 or horizon. So 0, 0, and P, you see that 0, 4. And when it comes to OQ, O is 0, 0, and Q is 1, 3. Okay, again for your comfort, just I am writing this one as x1 y1, x2 y2, x1 y1, x2 y2. Okay, now I want you to compute all the three lengths, all the three distances using the distance formula. Now your time starts. Okay, now let's look at the answers. When it comes to radius, it's pretty easy. You can plug in the values, you get 4 units. And here the most possible mistake is when you take negative 4 whole square, it is not negative 16. It is negative 4 times negative 4. That gives you positive 16. Okay, so don't make that kind of mistakes. And when it comes to the length of OP, this one just plug in the values here also you'll get 4 units. And coming to length of OQ, then you get that it is square root of 10 or 3.16. Now, when I compare, I see that the first one, the radius part, the radius, my bad. So the radius is, you see that it is square root of 16 or 4 units. Okay, so this is say that 4 units. Okay, and next length of op is also 4 units. Therefore this one must be lying on the circle because the radius equals to radius, so oa is radius and op is also radius. And coming to the length of OQ, I see that that is shorter than the radius, shorter than the radius. Therefore, can it be outside or can it be inside the circle? It is less than 4 means it is 3, let's say 3 units or 3.1 or 3.2, whatever the value may be, that is shorter than the radius. Therefore this one must lie inside the circle. So you have to justify your answer also, like it is less than radius, that is in the interior of the circle, and if it is more than radius or longer than the radius, then it should lie outside the circle. Okay, any questions on this? Okay, let's go to the next one. Name the triangle formed in the given diagram. Actually here the values are not marked, so I see that point k is on x-axis. I see that this is going to be -4, -4, and on y-axis, you know that the vertical line is the y-axis. So here it is 8. So -4 comma 8, then point L, it is -7, and the value of y is 4, -7 comma 4. Coming to m, x value is, it is 2, and y value is, oh my bad, it's -2. See, these kind of mistakes we are tend to make because all the x values on the left side of the horizon, therefore all the x values are negative, and all the y values, they are above the horizon, therefore they are positive values. Now if you are taking, say, let's say KL, then LM, next to km. So all these three lengths we have to find. As I told you before, every time I would like to write the distance formula, which is x2 subtract, one moment. So let me write the points to point k, that is -4. It is -4 comma 8, and point L is -7 comma 4. Okay, then the distance formula, which is x2 subtract x1 whole square plus y2 subtract y1 whole square. Okay, then let me label them as x1 y1 x2 y2. Whenever I solve the problems, always I write the formula and I label the parts this way. You too do the same way. X2 subtract x1 is negative 4, so please see that here there is a double negative sign. Okay, therefore this is so let me use extra parenthesis square plus y2, which is 4 subtract 8 whole square under the square root. Okay, now I want you to take charge from here and I want you to compute the length of LM and KM. Now your time starts. Okay, now let's check the answers. The length of KL, I see that square root of 25. If you want, you can write it as 5 units also. And length of LM, my bad. Okay, length of LM is going to be square root of 34. Square root of 34. And you may check your calculations with my calculations. Length of km is going to be square root of 53. Now I see that here one side bad. So one side is square root of 34 and the other side is square root of 25. I told you that if you want you can write it as just 5 and square root of 53. So I see that all the three values are different, therefore it must be a scalene triangle. It must be a scalene triangle. Any questions on this? Okay, let's go to the next question. This one is again, you have to find the length of all the four sides. I'm not going to spend much of time on this. So let's say that you computed, and I'm sure that you know how to find the length of BC, AB, AD, and this one. And from the diagram itself, we can sense that this is not a square. Let's say that you got all the four sides are equal, then you can say that it is a rhombus in case if you get. Or else just assume that you got the opposite sides are equal. Honestly, I did not compute and I did not, I don't know what are the answers. Let's say that you got square root 50, just I'm giving randomly some numbers. They may not be accurate and you may not get the same answer. Let's say that you got all the four side values are this way. So you can say that all the four sides are equal, then it is a rhombus, right? Whereas in case if you get, say this is some say 38 and this one is 38 kind of thing, so you can say that opposite sides you see that length of BC is square root of 50, this one is also square root of 50, whereas the other two sides you see that this is 38 and this one is 38. So opposite sides are equal, and I can say that it is a parallelogram, not a rectangle, because the corners are not at 90 degrees. Okay, so let's go to the next question. Before that, do you have any questions about this? All right, let's go to the next question. Name the given quadrilateral. Again, I told you that the previous question, you make sure that you are computing all the four sides. Let's say A, B, C, D. Okay, in case what are the length of AB random. Oh, in this question, you know, an interesting thing, I need not use that distance formula for computing AB because I can count the number of blocks. Does it make sense? Like hey, it seems this is off, or I'm sorry, it is supposed to be completely on this one. Please excuse me while making the diagram. The point is completely not on that. So please consider this point also. 1, 2, 3, 4, 5, 6. 6 units. 1, 2, 3, 4, 5. This is also 6 units. But here you have to use the distance formula. Let's say that you use the distance formula, you got some, just I'm taking some numbers randomly, they may not be correct. In case if you get this kind of scenario, you see that opposite sides are equal, therefore can it be a rectangle, means the answer is no, because the corners are not at 90 degrees, right? In case if you get, let's say that you computed and you got this one is 6 units and 6 units, you see that all the four sides are equal, then you can say that it's a rhombus. Okay. If diagrams are not given, what to do means, I mean, in the previous session, I explained that you have to go an extra mile and you have to compute the length of diagonals. Suppose if all the four sides are equal, it could be a square or a rhombus. If you are not given the diagram, just only 4 points are given. Then in such case, you have to find the length of diagonals. In a square, the diagonals are equal. In a rhombus, the diagonals are unequal. Likewise, in a rectangle, the diagonals are equal, and in a parallelogram, the diagonals are unequal. Please refer to the previous sessions in case if you are having any questions. Okay, so let's go to the last part, which is the summary for the day. So in today's class, we revised and quickly we revised that the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square under the square root. This is derived from the Pythagoras theorem. As I told you before, if you are taking the vertical blocks, you can count. The vertical blocks you can count, and the horizontal blocks also you can count. But the slanting one, which is the hypotenuse, this cannot be computed where we use the distance formula. Where we use the distance formula to compute the distance between 2 points. Okay. And the second thing is, while writing the values, please be very careful, especially if there are the double negative values, like you see the double negative signs. In such case, please take an extra parenthesis and multiply negative of negative or positive times negative, whatever it may be, you have to multiply them. Okay, and this is 1, and so it's going to be 5 plus 2 square, that gives me 7 square. Again, if there is let's say that negative 4 whole square, and this is not negative 16, this is not, because negative 4 whole square means negative 4 times negative 4, that gives me 4 times 4 16, negative of negative positive 16. So you have to be really careful with the negative signs. Okay, and again, when it comes to triangles, if all the three sides are equal, then that is equilateral triangle. If only two sides of the given triangle, you know how to compute the length of each side. Only two sides are equal, then isosceles triangle. And if no sides are equal, then it is called as a scalene triangle. No sides are equal, scalene. Two sides are equal, it is a isosceles triangle. If all the three sides are equal, that is a equilateral triangle. Okay. Okay, so please refer to the properties of quadrilaterals too. Okay, that's it.